example 5. Okay, this one is from problem 4.2. Okay. If look at here, okay, table B.2 in appendix B. Okay, provides parameters, okay, for an equations that give P saturated as a function of T. So I think you have to refer to the appendix B, okay, B2. So this appendix, B2, okay. So where's appendix B2? Not here, I think. I think it's in the in chapter 4. There is the appendix B. Okay. Example 4.12, right? Let me check first. Okay. So it should be in the this one. Chapter 4. Okay, please refer there. As a function of temperature for the number of pure component, determine the heat of evaporation acetone and its boiling point and application of Clapeyron equations. Evaluate dP saturated divided by dt for the given vapor pressure equation and use generalized correlation from chapter 3 to estimate delta V. So meaning that they have vapor and liquid. Okay, this is a two-phase system. Uh, and then compare the computed value with the value of delta Hn. And this is the given listed in table B2, right? So the additional information is given below. Okay, Clapeyron equations stated that delta H evaporation equal to T delta V dP divided by dt. And generalized correlation from chapter 3. So this one you have to use. Okay, Z plus 1B not plus omega B prime. And also V saturated. Okay, that one is for the liquid. Okay, because you have to determine vapor, liquid and vapor, because you need to determine delta V. Okay, and any questions, A, B, and S also C. Okay, so if you look at here that I just uh, give you the step. Okay, and then you can proceed. Um, what you have to do is you have to refer to table B1. Okay, table B1. Okay, table B1. Okay, finds the value of omega for acetone, TC, PC, right? ZC, KVC, and then it's also TN, pressure, and also delta HN. Delta HN. This one is given. Okay. 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 So this one is from table B.2. Hn is equal to uh, P equal to 1 atm. This one you determine. Okay. Tn is equal to 329.4 Kelvin. Okay. So this is the pure substance. Only acetone. Okay. So once you determine TC, PC, TNs, please determine TRN. So to TN divided by TC. Okay. Please determine. And then PR. So PR P divided by PC. So we calculate from the boiling point state. Okay. Okay. So once you determines, okay, by using generalized correlation to you have to use what is it? It's given virial right. Okay. So you have to calculate volume for the vapor, okay, VV, and also VL lah for the liquid. Okay. So what you have to do is volume for vapor lah. Okay, this one how you determines, okay, just using the given equation Z, please calculate, equal to 1 plus B naught, okay, PR divided by CR, CRF. Okay, so this one TRN, okay, plus omega, okay, B prime PR divided TR, okay, this one TR. Okay, so please determine Z. Okay. So once you determine Z, okay, V equal to Z R T and divided by P. So you can get VV lah, this one. Okay, this one is for vapor. Okay, so this is the first step. You have to determine vapor volume. Okay. Faham eh? Okay, next. Okay. We have to determine liquid volume. Liquid volume, okay. So for the liquid volume, you just use V saturated equal to, is it VCZC, right? 1 minus TR. This one TRN, okay? Okay, and power to 7. Okay. You refer back from chapter 3. So you can get the answer. Okay, V saturated. Okay, so this one is for V liquid lah. Okay, and then you can substitute how to determine the delta V. Okay, so to determine delta V, what you have to do is V vapor minus V VL. Okay. Okay, from the equations, delta H, okay, equal to T delta V dP saturated divided by dt. Right. Okay. From the Antoine equations, okay, Antoine equation ln P set equal to A minus V divided by P plus C lah. Okay. So just rearrange equation, this one, in term of P saturated. Okay. Exponent lah. A minus B divided by T plus C. So, and then you have to differentiate. Okay, because this one in term of dp dt. Okay, so how to differentiate? So if on the left you differentiate, on the right equation also you have to differentiate. dp saturated divided by dt lah. Okay, so we can get the final one equation. Once you differentiate, you can get b divided by t plus c power of 2. E exponent, okay, power of a minus b divided by t plus c. Okay, exponent. Okay, and then you substitute into this equation. Okay. Okay, and then next, just solve it. Okay, all you have to do, just substitute into the equation delta H. Okay, calculation equal to Tn, right? Delta V is from the, and then dp dset, right? Dp V S divided by Tn minus 273. Okay, plus C. Okay, then exponent lagi. Tulis exponent. A minus B divided by Tn minus 27.1 divided by Kelvin. This one is Kelvin. Okay, just divide by Kelvin because we want to convert to degree C. Plus C. Plus C. Okay, plus C. Okay, so you can calculate delta H. Then to calculate the error, this one delta H calculation. Error equal to delta H calculation minus delta Hn divided by delta Hn. And 100. So you can get answer the error. Please calculate. Vapor volume. Who's calculate already? Vapor volume. Anyone calculate? Ikram? Ada calculate tak? Delta H volume. Ikram? You there? Did you calculate the delta pula. Vapor volume and also liquid volume?
Not yet, doctor.
Okay. So please calculate. Ini pun dah berapa minit? Okay. Anyone already calculate? Okay. So once you calculate vapor volumes and also liquid volume, determine delta V. Okay, VV minus with VL lah. Okay. And then you have to determine dp dset, right? Okay, dp dset you just substitute into this equation now. A and A, B, C. Please refer to the appendix to determine A, B, and also C for the acetone. Okay. So just substitute all the informations that you determines into the Laplacian equation, and you can calculate delta H vaporizations. Okay. So actually, once you calculate delta H, this one is the error is not really difference now. It's below than 2%. Okay. So that's how you calculate how to use the what is it? Clapeyron equations to calculate the change in the enthalpy lah. Okay, for two-phase system. Okay. Okay, any questions about this example before we move? Any questions? Boleh tak? Is it you can calculate or not? Afika Siddiq, can you calculate? Okay. So is it clear? If no questions, I want to move to this one. Okay. Next, what is it? Next, example. Okay, no questions, okay? Okay, so let's we move to anyone? Havika, V paper dapat?
Doktor, tengah
Dapat?
kira.
Tengah kira lagi. Lamanya. V paper dapat ke? Please get the value of V vapor, V liquid, what else? Z. Z, this one lah. You have to calculate the V vapor, right? Z. And then delta V. Okay. And then what else? Okay. dp set lah. Divided by dt. Right, because of this one. Okay. Ap is at the end lah, because you calculate from the normal boiling point. Once you determine this one, you can calculate delta H. Okay. Is it clear, the step? I don't remember this one. Where did I get this example? Okay, so we move to next examples, which is tutorial. This one is tutorial. Okay, so if you look at here, right, tutorial part, tutorial, tutorial. Okay, so if you look at tutorial 3, okay, saturated liquid benzene at pressure P1 equal to 10 bar, okay. T saturated is given for the first condition for 151.7 Kelvin is throttle, okay, in a steady flow process to a pressure P2 1.2 bar, T2 saturated, right, T 158.7 Kelvin, where it is a liquid vapor mixture, meaning that from the liquid, right, saturated liquid is a this one, right, it's starting from this one. Okay, if you remember PV diagram, I started from here and then throttle. Okay, if a throttle to first, I'm not sure this one is because this one is V, right? Oh, so difficult this graph. Okay, so I think is a maybe from this condition. Okay, 10 bar, right? This one is pressure, temperature. 10 bar, 354. Okay, I think is this one to this second condition. It's throttle to this one. Okay, vapor. This one vapor, solid liquid, right? So maybe it's just around this one to this condition. Okay, because change in temperature and also change in the pressure. Okay, okay, saturated liquid maybe is uh with in this line also lah. Okay, but is we know that the final condition is already is become liquid and vapor mixture. Okay, estimate the molar fraction of the exit stream that is vapor. Oh, okay, sorry, fraction of exit stream that is vapor. Okay, so we want to the fraction of the vapor. Okay, since there is a liquid and vapor, so the at the final state, so we want to the fraction, meaning that the x lah. Okay, the fraction. For liquid benzene, Cp is given, so ignore the effect of pressure and enthalpy and liquid benzene. Okay, so Cp is T1 saturated minus T2 saturated equal to x saturated. So this we have to find this x. Okay. Okay. So what you have to do is yeah, the pure substance is benzene, right? So this is benzene. Benzene, right? So find Tc, Pc, and also Tn lah. This one is from table PB1. Okay. Yes. T1 saturated is given. T2 saturated is given as well as Cp lah. Okay. This one the information given. Okay. This information is given. Okay. Tc, Pc you have to find. Okay. So it's stated that the conditions first condition in saturated vapor saturated liquid, right? Okay, and then is throttle to the final conditions consists of liquid and vapor. So actually we can use the Riedel equations. Okay, first condition we know because if you calculate at saturated liquid, so meaning that you can calculate at the normal boiling point at that state. Okay, so how can we do is just using the Riedel equation delta equation, okay, divided by RTN. Okay, Riddle we calculate at normal boiling point. Okay, 1.092. Right, ln PC minus 1.013. Right, divide by 0.930 minus TRN. Okay. So how to determine TRN? TN divided by TC. Okay. So please determine TRN. First condition. Okay, this one is TRN1 lah. First condition. And second condition is TR2. Saturated lah. So this is a T divided by TC at the final. So it's given T2, right? Okay. So just substitute into this equation so you can get delta Hn. Okay. So this is a Riddle equation. From this Riddle equation, we can get delta H2 by using correlation between Watson and also for the Watson equation by using information that we get from the Riddle. Okay, so please find this one delta H. Okay, so you can get this one. Okay. So by using a Watson equation, if you still remember delta H2 divided by delta Hn, H1 lah. Lepas tu 1 minus T R2 divided by Allah. Delta H2 minus delta H1 equal to 1 minus T R2 divided 1 minus TR1 lah. Okay. This one 0.38. So this one you can arrange because you want to determine delta HB, right? So delta HB H1 become delta Hn. Okay. 1 minus TR2 saturated. 1 minus TR and 0.38. So delta Hn you calculate from Riddle equation, TRN also from Riddle, TR2 is given. You have to calculate lah because T2 saturated, T2 is given. Okay. So once you determine delta HB, okay, you can get delta HB lah. So from the correlation, from the equation Cp, from the information is given, right? T1 T1 saturated minus T2 saturated. Okay, equal to X delta HB. Okay, this one. Just substitute and you can get value of X. Yeah, value of X. So this is the step. Okay, so you can get the answer. Hafikah, delta HB tadi berapa? HB dengan HR. Yang example 5. Masih calculate lagi?
Tak dapat.
Tak dapat? Kenapa tak dapat?
Tahu lah.
Hmm? Anyone? Ikram? Ada dapat Ikram? Vapor volume for example 5? Tak dapat agak? Okay. For example 5, vapor volume you just using a virial generalized correlations. Z equal to 1 plus B naught PR divided by T, KR plus omega B1 PR divided by T, TR. So B naught is you just get the equation from the chapter 3 and also B prime. Okay, all the equations is from chapter 3. Okay, and omega is you get it from the table B1. Okay. Okay. And TNs I gave the TN already. P is 1 ATM and TN is equal to 329.4, right? That one is from table 2, right? Okay. Okay. Anyone? Give me the what's that? Who give me the tak dapat juga. Kenapa tak dapat juga Ikram? Macam mana awak calculate? Chapter 3 faham tak? 26, yes. Thank you. Who's that? 26018. Okay, please share with everyone, not privately to me. I don't need the answer. Okay, I tell you many times. Two 2.61. Okay, do not forget the units. Okay, times 4 lah. Okay, thank you Chai Won. Okay, so you need the knowledge from chapter 3 actually. Okay, and then from the equation from the liquid volume, you have to use the Racket equations. Just substitute all the value and you can get VL. Okay, then you can get delta V lah. Okay. Okay, please proceed. Later maybe I will put it as a assignment lah, since you macam ada yang tak dapat lagi kan. Okay. How about this tutorial 3? How about tutorial 3? Can you any question about that tutorial 3? Later you do at home. If you can try. Maybe next class I want to know the answer. I already give you the step how to solve tutorial 3, right? And also example 5. Please calculate. If you give me the final answer, there's not going to be tutorial from this example. Okay. Is it clear for tutorial 3? This one, tutorial 3. Any questions? It's okay. You can ask the questions. Afiqah ada soalan tak Afiqah? Tutorial 3. Afiqah?
Tak ada, tak ada. Saya try buat.
Try what? Ikram? Is it clear the step? Okay. Since no question, so I guess it's clear. Because next class, I want to explain about the heat of reaction and heat of combustion, as well as what? heat effects on the industrial reactions. I'm not sure I can make it or not. No, this one. Just saya delete pula benda tu. Tak apa. Okay, so we see on the tutorial 4. Any question about tutorial 3? Or tutorial or example 5? Tak ada eh? Is it clear? Okay. So for the tutorial 4, estimate alamak ni you need a delta H formation. I still did not explain the delta H formation. Hmm. Wait, estimate delta H for Australia as a liquid at 25 degrees C. You need a delta H for formation. It's okay lah, KIV, because I'm still not explain the delta H formation. Later I will explain it. Where is it? Delta H formation. Yeah, in this one. Yeah. Okay, for tutorial 3, please calculate what you the important answer that you have to determine is delta Hn. Okay, delta Hn you have to determine. Okay, and then uh, delta Hv lah from the Watson. Okay, from this one, from the CP1, T1 saturated minus T2 saturated equal to X delta Hv. So that you can get this fraction. Okay, any questions before we stop? For the example 4, I think it's later because I'm still not explaining the delta heat formation. Okay, any questions? It's almost 5 questions. I think for 1 hour is very short. Ada soalan tak? Assignment already submitted for chapter 3? Is it submitted already? Okay. So if no questions, please do example 5 and also tutorial 3. Okay. I want to know the answer in the next class. So if okay, I just randomly pick one name. If no answer, I will make it as an assignment. So meaning that your assignment, the question will be is it many questions? Okay. Other than the previous one, I'm not assigned as a assignment. So because everybody is cooperate with me, give me the answer and also yeah, during the discussion, right? So they give me the answer. So I will not assign it as a assignment. Okay. Oh, anybody already already get the final answer for this one? Anyone? Okay. For the example 5. Final answer. All right. Okay. So it's okay lah. I will ask again in the next class. Okay, and then we will move to heat of reaction and also heat formation, heat combustion, as well as how to use the hypothetical parts to calculate thermodynamic properties, especially change in the enthalpy. Okay. Okay, that's all. Thank you very much. See you again for the next class.